Okay, this is the last one that you're going to be putting in your notes today. It's the guided practice. It is the page that I'll do with you before you get independent practice of this skill, and it will look the most like the independent practice and ask the same type of questions. So it says, for the directions, write all names that apply to each number. So the names that they're asking for, like, is it a real number, is it rational, is it irrational, is it an integer, whole, or counting number? We want to write everything that this one is. The key to be able to do this well is that you need to write every number in its decimal form. So right here I have a fraction, and we have a calculator. So if you've put yours up, go get it back because you need it. Don't just watch me do it. You need to practice typing it into your calculator, so whenever it's time for you to do it on your own, you've already done it with me, so it's easier. To type in the fraction 7/8, you do 7 divided by 8. Some of you probably remember 0.875. Oh, it's telling me my battery's low. 875. Okay. Now, we're going to start with the top of that flow chart that we just did. That was like this. So at the top it says real numbers. Well, everything in the 8th grade is real, so we do get to classify it is real. And then it broke down into 2 different sections. So I have to figure out, well, which way does it fit? Because it doesn't go both ways. I have to pick a route. Okay, it can be rational or it can be irrational. We said over here that it was decimals that can repeat or terminate. On the other side, we said it was a decimal that never ends and never repeats. So looking at this one, I see that it ends right here. It only goes 3 places and then it stops. Since this is a decimal that ends, we're going to name it rational. Okay, you always try to keep on flowing down that flow chart to see if it fits anywhere else. It said to name everything that it can be, that it would apply to. An integer, a negative and positive number, and 0. If I look at these and I look below it, and this one had 1, 2, 3, 4, none of these have decimals. So this decimal number that I'm looking at doesn't fit there. It's not an integer. It's not a whole number because it's a fraction. And it's not a natural counting number that you started with in kindergarten, so it stops right here. Number 2, if you do the square root of 36, you get the answer of 6. That is a real number. To make it a decimal, I can make it 6 decimal 0 because I needed to know whenever my real number branches into 2 parts, is it rational or is it irrational? This is a decimal that stops, so it is rational. If I think about how I originally had it, it didn't have a decimal, it just had the number 6. So if I keep on going down my flow chart, integer, I have to ask myself, could this list count to the number 6? Of course it could. So I'm going to put integer, comma, keep on going. Underneath integer is a whole number. Could I continue that list? Yes. The natural numbers, like counting in kindergarten, 1, 2, 3, 4, 5, 6, definitely. So whenever you have a normal number, like the number 6, it fits all these categories, everything that we talked about except irrational. Real, rational, integer, whole, and natural. I'm going to have to upload this video because the space is running out on my iPad.